All right, so for 12.3, this is what we didn't get to yesterday in class. This should be in your notes packet on the very last page of the notes packet that I handed out yesterday. All right, so where it says find the range, given the domain, anywhere you see the word range, you need to think y's. Anywhere where you see domain, you need to think x's. So find the y's given the x's is basically what this means. And notice, and I have it underlined here, but notice it says, right, write your answer as a set of ordered pairs. What's another way to say a set of ordered pairs? A relation. Okay, so if you see in your directions, if it says write your answer as a relation, it means write it out as a set of ordered pairs. So our final step for each one of these, once we find the range, is we're going to write it out as a set of ordered pairs. Now, these are a little bit time consuming, and you may need to use a separate sheet of paper or the back of your homework, okay? Because if you are given 4 x's, right, which you are here, that means you're going to have to work this problem 4 times to get 4 different y's, and then you're going to have 4 points. So you really have to do y equals 3 times, go with your first x, -2 plus 2. 3 times -2 is -6 plus 2, which equals -4. So my first ordered pair, I'm going to come down here just to save myself some time. When I plug a -2 in for my x, I get a -4 for my y, right? That's my first y value. Now I'm going to work it again with my other, my next x value. So y equals 3 times -1 plus 2. 3 times -1 is -3 plus 2 equals -1. So my next point in my relation is going to be -1, -1. Because when I plug a -1 in for the x, I get a -1 for the y. Now I'm going to work it again. Y equals 3 times, now I'm going to do my 0. 0 plus 2. Well, that one's easy. 3 times 0 is 0 plus 2 is 2. So my next point would be when I plugged in a 0 for the x, I got a 2 for the y. And then lastly, I'm going to work it with my 3 from my domain. So 3 times 3, because I'm going to plug that in for my x plus 2. 3 times 3 is 9 plus 2 equals 11. So when x is 3, y is 11. Okay, so now I still have to go back because notice what the very first thing in your thing was. Find the range given the domain. So I need to come up here and I need to state my range. Well, my range was -4, -1 to 11. So -4, -2, no, -1, sorry. -4, -1 to 11. That's my range. So you need to do there's a lot of little working parts to this. You have to work it all out however many times. Then you have to state your range and you have to write your answer in a set of ordered pairs as well, or write the relation. Yes. Oh, yeah, thank you. Yes, you do. Thank you. You do need to put the brackets because it does need to be written as a set of ordered pairs. And if I don't put the brackets at the end, you can grab a piece of candy if you want. If you don't put the big brackets at the end or those braces at the end, then it's really, technically, it's not a relation yet because you haven't kind of clumped them together. Yes. Oh, thank you. Sometimes I get quick and lazy. All right. So work it however many times you need to work it, write your set of ordered pairs or your relation. And if you want to do this, when you get your homework, just kind of right off the bat, just to remind yourself that you are going to go in and you are going to state your range. And then you're also going to write your answer as a set of ordered pairs at the bottom. Okay. All right. So let's work. Well, I'll do this one with the fraction. So y equals 1/2 times -4 minus 2. Half of -4 is -2 minus 2, which equals -4. So my first ordered pair would be -4, -4. Then I work it again 1/2 times my next x value, which is -2 minus 2. Half of -2 is -1 minus 2, which equals -3. So my next ordered pair would be -2, -3. And then 1/2 of my next one, which is a 6 minus 2. 1/2 of 6 is 3 minus 2. So I get a 1. So when I input a 6, my output is a 1, or my y value is a 1. And then lastly, y equals 1/2. I plug in the 8 minus 2. Half of 8 is 4 minus 2, which equals 2. So my last point in the relation would be 8, 2. So there is my relation, my set of ordered pairs. And then I'm going to come back up here and I'm going to write my range. And my range was all my answers: -4, -2, -3, and 2. So writing them in order of least to greatest, I'm going to put -4, -3, -2, and 2. So two points to your answer. One is the range, and then the other is writing everything as a set of ordered pairs. Uh-oh, I see lots of hands. What'd I do? What'd I do? Oh, yeah. I got you. All right, you guys can, if you had your hand up, grab a piece of candy. A lot of honor system here on your candy grabbing. All right, so yeah, sorry, my other y was, so -4, -1. All right, there we go. I should have, instead of looking at all of my work, I should have just looked at my set of ordered pairs to see my range. All right. I'm not going to do both of these examples at the bottom, 3 or 4. I'm just going to do one of them because then I also want to do an example there at the very bottom. So you do it the same, even so on these first 2 examples, our equation was in y equals mx plus b. In our next 2 examples, it's not in y equals mx plus b, but you still do it the same way. Okay, so I'm going to do, you still plug in, and it doesn't matter where it's at in the equation. So your domain is your x's, right? You're still going to put a parenthesis where there's an x. You're still going to plug in first -5, then -1, then 0. And then you're still going to work it. You're just going to have to do a little bit more algebra when you work it. So I'm only going to do one example to number 3. I'm not going to do all of them. So for number 3, you would have 2y equals 3 times my first domain is -5 minus 1. 2y equals 3 times -5 is -15 minus 1. 2y, -15 minus 1 is -16. Divide by 2 and divide by 2, and y equals -8. So you can see they get a little bit more complicated in the algebra, but you still do it the same way. You still plug it in. You still plugged in a -5. It was your input. Your output was a -8, and that's your first point. And then you would work it again, plugging in a -1 and a 0 to get your other 2 points, and then you would state your range, okay? For number 4, again, the equation is in a little bit different order, but that's fine. You still work it the same way. Domains are always your x's, so find your x, put a parenthesis. So -2 times your first x, which is -4, minus y equals 3. -2 times -4 is +8, minus y equals 3. -8 minus 8 leaves you with -y equals -5. Divide off the negative and you get y equals +5. And so your first ordered pair would be an input of -4 with an output of 5. Okay. Now, I will tell you this, it wouldn't really work really well with number 3 because that would give you a fraction. But with number 4, if you wanted to, you could -2x minus y equals 3. Could I put this in y equals mx plus b first? Like just my generic equation. So what if I add 2x and I add 2x? That would, If I added 2x to both sides, that would leave me with negative y equals 2x plus 3. And if I divide off that negative, that would leave me with an equation of y equals negative 2x minus 3. Is this right here equal to this right here? If I did my algebra right, it is, right? They're the same thing. They're just written in a different order. Now let's do that exact same one. Let's plug in negative 4. Okay, so y equals negative 2x minus 3. Where there's an x, let's plug in that negative 4 that we just did. Y equals negative 2 times negative 4 minus 3. Negative 2 times negative 4 is 8. See how I get the same answer? Does it make sense? You can either do the algebra once and get yourself a more simplified equation to use all the way through it, or you can use the original equation and just have to do the algebra part 5 times. It doesn't matter to me which way you do it, whichever way makes the most sense to you. This is just kind of a shortcut. I like to show you. If it confuses you, ignore it. If it helps, use it. Okay. All right. On the bottom, again, there's really no shortcut through. I mean, there's really no easy way to do this other than you have to work it, in this case, 6 times. So I'll show you why. It wants to know which points are a solution to the equation. Yes. Do what? I would rather you show your work, because if you get one wrong, I can't look in your head and see what you did. So I'd rather you write it out to show me what you did. Okay. And I'm even fine if you're, I mean, really like this one, if in your head, you know that that's negative 3 plus 2 and you want to skip this step, I'm fine with that. Right. If you wanted to skip this step, I'm fine with that, but at least write out what you plugged in so I can kind of follow your train of thought. Okay. All right. Huh? Oh, okay. All right. So where it says to check, okay, check all the points that are solutions to the equation. This is an X and a Y, right? My equation is Y equals 3X minus 5. Where there is a Y, I'm going to plug in the Y value of 2 equals 3, parentheses minus 5. Where there was an X, right, in the equation right here, I'm going to plug in the X value of 3. Now I'm going to evaluate and see if I get a true or a false statement. So just 2 over here because there's nothing to evaluate. 3 times 3 is 9 minus 5. 9 minus 5 is 4. Does that check out? No. So that is not, well, I would put no. Or if you want to just leave it blank, but just remember that you've done that one, right? You can just put no here or you can leave it blank. Because 2 does not equal 4. All right, now you got to do it again with 2, 1. So I'm going to plug in the 1 because that's the Y value. 1 equals 3 times the X, which I'm doing this point here. I'm doing the 2, 1 point. So 1 equals 3 times the X value, which is a 2 minus 5. 1 equals 6 minus 5. 1 equals 1. That one checks out. So this one would be a check. Check all the points that are solutions. So if you get a true statement, it's a check. If you get a false statement, then either leave it blank or put no. And again, really, there's no shortcut through this. You just have to work all 6 of them and just see which ones are true and which ones are false. So for the negative 1, 4, the 4 value is the Y. So it's Y equals 3 times the X, which is negative 1 minus 5. 3 times negative 1 is negative 3 minus 5. 4 equals negative 8. No, that one does not check out because 4 does not equal negative 8. Then you take the 0.46. Again, remember which one's X and Y. Honestly, that is the hardest part of this, is just not flip-flopping your X's and your Y's. Know what goes where. It's Y equals, so 6 equals 3 times Y minus 5. 3 times 4 is 12 minus 5. 6 equals 7. That's not right. So no, that's not a point. So then we take the point 0, negative 5. So negative 5 equals 3 times 0 minus 5. Well, that's easy. 3 times 0 is just 0. Negative 5 does equal negative 5. So yes, that one works. And then negative 11 equals 3 times negative 2 minus 5. 3 times negative 2 is negative 6 minus 5. Negative 11 does equal negative 11. So yes, that one checks out. Okay. And again, there's no quick way around it. You just have to work that problem out 6 different times to see which ones are yeses. I'm only going to work one of these just to show you. You do it the same when it's in any form. It doesn't matter. Your X is still your X. Oops. Your X is still your X. Your Y is still your Y. Okay. So when you plug it in, it is 4 times your X plus 3 times your Y equals 9. 4 times 3 is 12. 3 times negative 1 is negative 3. And 12 minus 3 is 9. So yes, that one checks out. So just plug it in. Anywhere there's an X, plug the X value in. Anywhere there's a Y, plug the Y value in, and then evaluate it to see if it's true or false. All right. All right. For those of you in my second hour, I apologize for not getting this done Tuesday in class. Thank you for watching the video. And if you have any questions, email me for 12-2 or 12-3, both of which are due tomorrow.